Hey, people. I hope the energy levels are still high here in the happiness room. If not, do not panic. Veronika Romashkina is here to make us LOL. Is it just me or do other people actually pronounce it as a single word too, like lol? Anywho, Veronika is also no stranger to the Haskell community. She is also half of Koenig, the well-known open source team that keeps putting out amazing content, initiatives, and infrastructure for open source Haskell. If I'm not wrong, Veronika is also responsible for all the artwork and general fun tone of Koenig things. She also brings a lot of experience from applying her Haskell skills for the good in important but enterprising fields like healthcare, insurance, mortgage, etc. Feel free to ask any questions during the talk. Veronika will try to answer if possible. Otherwise, we always have the spatial chat Q&A session. And I'll be collecting all the questions in Discord. All right, so Veronika Romashkina, Haskell lol.
Thank you very much, Kartik. Very nice introduction of myself. Yeah, today I have a talk which is Haskell lol, and this will be about very weird moment of Haskell code and what it can bring to us. As you see from probably the first slide, the talk is going to be very informal, and I hope it will be very lightweight and easygoing. So just grab a coffee, tea, or something and sit and relax with me. I hope you will enjoy that. In this presentation, I will show a lot of code snippets and all of them in Haskell. So this talk is for any level of experience. However, a basic understanding of Haskell syntax would be a good start, but I still will be explaining a lot of stuff on the fly. So let's start. Yes, as it will be very informal talk, let's first meet and get to know each other. I'm Veronika. You can find me as Rom911 everywhere. And I love Haskell. I'm a Haskell developer. I have more than 4 years of experience working in different companies with Haskell. I also love open source, and yeah, Koenig is a project that me and Dmitry, who is actually also doing a talk today at this conference about one of our libraries as well. And yeah, Koenig is a place where we do a lot of experiments, projects, mentoring. We're writing a lot of blog posts, tutorials, and yeah, actually experimenting with functional programming. Yes, this is me. And what is this talk about and how I came up with the idea? I guess we all seen some weird snippets from very different languages, but most probably it was something very strange from JavaScript. And I saw this talk about JavaScript, which is actually focuses on such moments and trying to not only trying to explain, but just trying to show it and explore that. And I thought that actually we are not so different from the other languages, because sometimes I also feel like something is counterintuitive in Haskell as well. Though I know that Haskell should be like more stable, more type safe. It allows us to write robust and determined code. So I thought that it maybe could be fun just to look over that stuff. And yeah, and that's how this talk came together. You can ask, but why? Why should I do that, and why you should be listening? Well, this is a nice question, and here's a few points I can say about why we should do that together. First one is to reflect on the language. We're all working in one way or another with Haskell a lot, and sometimes you need some high-level glance on what you're doing with the language and what is weird and what is normal in there. So sometimes you need to refresh and see stuff from outside as well. Of course, I want you to relax. This is a great conference, and this is just the start of the program. So there will be a lot of very exciting talks in the future, right after me. So this is the place where we can just sit, relax, and just maybe have fun, and don't push a lot on our brains to digest all that stuff, just to be prepared for all the hardcore stuff that is already coming soon as well. Also, as I mentioned, that a lot of languages are, well, not a lot of, mostly the JavaScript is shown as the language in which there are a lot of very weird stuff going on. In this talk, I want to show you that it could happen in every language, and every language is very unique in the way. So we need to be more patient to other languages. We need to learn from each other, and also, yeah, see what's going on in our language as well. And I want you to have fun as well. So let's begin. I want to start with a very interesting moment, which I learned a while ago when it was starting learning Haskell, but it still gets me every time. Let's break some math together. Okay, I can make a compiler to calculate 2 + 2 for me, right? And we expect it to be 4, but oh, look at that, it's 5. What's going on, you can ask. Well, I show you what I did before calling this command. So I just wrote that 2 + 2 is equal to 5, and now compiler tells me that it's 5. Okay, this is a strange behavior. So let's try to play with that a bit more. Let's try other example. What would happen if I want to calculate 2 + 3 then? And you see, here is the hint actually, which tells us what's going on. It says that pattern matching is not exhaustive with the function plus. So what happened is the first line we had in JS-like overrode the standard plus operator with integers. And we actually only define it on very specific pattern, where the first integer is 2 and the second also 2. And in this case, it's equal to 5. But on all other cases, it doesn't know what to do. So it's easy, it's sneaky, but you can do that. Now let's talk about pairs and tuples in Haskell. Let's see what we can do with that. Let's try the maximum function on this pair of 2 and 3. Well, we expect it to be 3 here, right? Because it's bigger than 2. So yeah, cool, everything is nice. And as suspected, let's try one more example, just in case, 2 and 1. I guess 2 is bigger. Ooh, that's strange, that's 1. That's really unexpected, right? But let's try as a function to see what exactly is going on and how it works. Let's try to see how a lamp function works. For example, I can see 2 in this pair for sure. So I think that this expression should give me a true value. Let's see, and it's true. Okay, nice so far. And in this pair, I also see 2. But what compiler says? It says false. And for the last, let's actually see how the compiler sees this pair of values, and the length of this pair is 1. Okay, you see that all these functions, they are generally functions that are working with some kind of containers, and when we're trying to work with them on tuple, it gives us not very intuitive results, not exactly what you can expect sometimes. And why is that? It's because it's how the foldable instance is defined for the pair. Let's look at that. This is exactly the code from base library, and it actually shows how it would work. Generally, we just skip the first element of the pair and working with the second one, which makes sense in some way. However, it's not always how people would expect that behavior from the pair of elements. The instance is very counterintuitive, and there are a lot of talks around that, that's good or that's bad, or it should exist or should be banned. However, it's what we have. One of the reasons probably we need that is to have the traversable instance as well, and for that you need foldable as it's a superclass for that. So yeah, it exists. So be prepared for that. And of course, we all love this composition and heteroreduction and stuff. However, sometimes we could be a little bit carried away by that. And I show you what I mean. Look at this beautiful function, flip, and yeah, I have no idea what this function could do. This point freeze style led to some crazy amount of dots, which I personally can't understand. So I will ask help of compiler to tell me what's going on. First, what I can do is to see the type. Probably it will tell me a lot about what actually is going on in there. And yeah, when I see the type, it all makes more sense here. So we given two functions that could change the values of the pairs that we also give as input, and we return new results based on the work of the function we provide. Now it makes sense. So I at least know which argument should I pass to this function. And let's see, yeah, if I pass these two functions to the pair of integer and string, I will get what I expect to get after the compiler helped me to understand that. But yeah, don't do that in production code. Don't do that in any code because it's very, very hard to read and work with. Another example, let's look at otherwise. When you work with pattern guards, which is what this function is written with. So you put some condition, and based on the condition, you have different actions. And I was always thinking that otherwise should be put as last piece, as last case of any pattern guard expression. And I thought that is a rule, that is a keyword that is part of this case. However, here you see the otherwise. Otherwise is just a function, just represents always true condition. So actually we can use it everywhere, and we can do anything with that. It's not a keyword, it's not like necessary. I can do this. Of course, the first condition of not otherwise doesn't make sense because it will never succeed as it's false. But yeah, still I can do that, and that's interesting, right? Yeah, cool stuff that we can write operators using emojis. This is very fun to do, and you can be very creative with this feature and can do a lot of stuff in probably that could help in learning, showing, and this is applicable to actually any Unicode symbol. However, yeah, and you see how it works. However, if you are using such operators in production, or if you are using emoji operators in your libraries or anywhere, I would suggest to provide a version which doesn't use any special code symbols, and but it's fun, right? It's fun. Now let's talk about SAC function. SAC function is a part of the enum type class, which just give you the next value of enum. Okay, which enums do we know? Integer, for example. So can we do SAC5? Yeah, it will return 6. Can we do this with a big number? Yeah, we can do that as well. What other enums do we know from the base? For example, let's take bool. That means that we can do the same with SAC, right? SAC false, it will be true. And SAC true should be, I guess, false. But no, it's not false. It's, yes, a runtime exception. So be careful with that, especially with the bounded enums. On max bound, all of the function from the enum, including SAC, will fail with a runtime error, which I guess is a thing you should know probably when working with that. Magic hash, let's talk about that. When I first saw this name in some model, I was very excited like that. I saw that some magical stuff will be happening on type level or something, and I will see some truly impressive stuff that's done in Haskell. However, in reality, this extension allows us to work with unlifted primitive values, which would be good for performance reasons. You could use this more low-level stuff to do a lot of things, but you can agree that based on the name, the thing it does not that exciting. Another thing that this extension gives you is the ability to specify your data types with a hash on the end. Without the extension on, you won't be able to introduce this hash in a data type, as as you will get the error which assumes that hash is an operator here. However, when I turn on this, I can do this stuff. I can introduce data types with a hashy thing at the end and anywhere. And yeah, it's not like it's a very nice feature, but maybe somebody will need that. It's just a cool side effect. And to be clear, you can introduce your operators with hash. However, you are not able to use it in introducing data types without the extension. As we hear, let's look at what this magic hash also gives us. We can use this primitive integer. We can use it with the 2 hashes to specify unlifted word. However, if we want to use it with 3, it doesn't exist, and it gives us this error, which is a bit misleading, as it says about incorrect indentation or missed brackets and stuff, which actually is not the case here for sure. But yeah, this is what we have. And as we're still on this magic stuff, let's talk about other thing. Let's talk about spaces and how important they can be. For example, here I'm just defining the hash operator, x hash equal. It's just magic, just very simple function operator, sorry. And let's try that. Yeah, it works without spaces. Let's see. It also works. What if we do this thing here where x hash applied to the argument? Yeah, it's not in scope because we didn't define that. That's okay. But let's look what happens when we have magic hash on. Let's do the same thing. We define the same function written in the same way. And yeah, let's try again with this thing and check how it works. Oh, variable not in scope. So it doesn't know about hash operator. What if we do this thing? Yeah, it actually works. So spaces are very important in this situation. And I want to mention that it's not only applicable to this extension and this particular symbol, but you can encounter that when you're working with a dot operator or dollar operator, because recent changes and adding new extension to your code could actually change the way the parser works for you. So be aware of that and don't get into the situation when you don't know what's going on with this. Okay, let's talk about our styly written and fashionable code, which we like to indent very perfectly and beautifully, and what it brings to us. Let's look at this function. Very simple function. It just takes two booleans, and what it does, it actually prints that. And we have the condition for each case, and yeah, that's basically it. Let's try it how it works. Okay, let's try this one on this result on false and true. Everything seems fine, right? It outputted what we expected. But let's try to do it with other arguments. Because, wait a minute, where is P2? It's not there. How did it happen? Well, actually, it happens in the function on the else clause. On the first else clause, it actually uses the second mapend to mapend to the string with a P1. And you don't have here two if statements. You have actually the nested if statement, because you didn't specify the brackets and how it should work. So be careful about that, because it looks like it is two cases, two if statements, but it's not. Fun story, I actually spent a few hours debugging the similar problem in code. So yeah, it happens. Be careful about that. Indentation not always tell you everything about what code will do. So be careful. Talking about indentation, we all know that you can't write the function body on the same indent as a function name. So yeah, this code shouldn't compile. And yeah, compiler said no, it doesn't compile. However, if we do this with a if statement, we can actually write then and else on the same indent level as a function name. Compiler says, yeah, that's good. Let's go. Okay, but what can it be? Maybe it's because the keyword is allowed to be on the first position and on the same level. Let's then change a bit our first function. Let's write in on the next line and indent it that way. Let's see if compiler is okay with that. No, it's not okay. It's still not working. Yeah, so Haskell parser is very tricky in some moments. So yeah, keep in mind that it could do a lot. We all been in this situation when we debugging thingy in debugging the parsing error, but it was just the wrong indent in let clause. So yeah, it happens from time to time, and be aware of that as well. Also, the fun thing is that this one, this function which specifies a record won't work. It says that the parse error on the opening bracket. However, if I will write it this way, leaving the opening bracket on the first line and then indenting all of my other records or with the same indentation as function, the compiler says, okay, no problem. So yeah, this also the case with language. Now let's talk about one-liners. We all love to solve challenges in the most short way and writing one-liners everywhere. And I feel very good when I find solution which requires very, very minimal code I could write. However, sometimes it could be a little bit a lot. Let's see. You actually can put the whole model on one line in Haskell, which I didn't think was possible. So you see, you can have all the language extensions. You can have the module name, exports, imports. You can specify data types. You can specify classes. You can even do inlining and having the default implementation for your class. You can write, of course, the functions as well. And it's all in one line. Yeah, you can do that, but why? I think it's not very useful. However, yeah, in most of the cases, people are using this feature of semicolons for writing the case clauses in one line, which could be neat, and some people prefer that. Yes. Okay, let's talk about let, where, and shadowing names and all of that. Let's look at this beautiful example. So here, what's happening here is we have the where clause inside the let, and we also have the where for the whole function. And we are using a lot of X, which is specific to each scope. So in each scope, we have different X's, and we shadow them each time. So it's very hard to understand, but you can do that. Let's talk about unexpected things that could happen as well. Yeah, we were talking about how JavaScript could be fun and weird when we concatenate the lines, or specifically when we compare some objects in there. But let's look at what Haskell has. Here we have a function where I want to write it in the way that it should check if the list is empty, and I'm doing that by having this check on if it's equal to the empty list or not. And it won't actually work. It won't work because this equal operator requires to have the instance of X to be able to do that. And here we don't have that. So this won't compile. However, if I write this thing in the terminal, I will get true. So it's almost the same, but it works. And we make fun of JavaScript comparing very different objects like none with a string or concatenate that. However, look at that. What we can do, we can also compare the string with a list, and it will give us a result. Yeah, the trick is that the string is specified as the list of characters in Haskell. So this is basically the syntax is sugar for the list, and that's why it works. It's not like different types. Don't worry that much. It's still the same type and type safe stuff. Undefined is very interesting function, and we usually use that to just close some stuff we didn't write yet, but we are going to. So we need just to compile as a part of code to see how it's working, and leave undefined as something that could replace anything. And if you take the challenge of writing undefined, how could you do that? And is it possible to have code with undefined which won't compile? Let's see. Actually, it's possible. And if we will take this function with this type, and we actually will be able to write a function that would do the trick. If we write here undefined, it won't work. Also, it won't work if we specify this as ID function. However, if we do the fg is equal g, which is basically the same as ID function above, but it would work. So ID doesn't work, but this thing works. Interesting. Also, we know that Haskell is good and functional programming because we have immutable states. We don't have a global variables. But let's look at this. I can do actually that. You see how easy I can have the global var. The important part here is having no inline pragma turned on for this function. And here you can do that. And more, and actually a lot of people are using that in production. And if you think you don't, maybe you do, because some of the very big libraries like Prometheus and stuff, they do have such function in their code. So basically you are transparently using that as well. So we are not all that innocent in global variables. Haskell has a very cool feature in the JS-like, which is called sprint. And what it does, it can show you on which state of evaluation your expression is in JS-like. So as you know, all expression could be evaluated in a few steps, and Haskell has this thing called chunks for things that are not fully evaluated to the normal form yet. Let's see what I mean. Let's have the example. We have this not true expression, which is not yet evaluated, right? It's not the concrete value. It should be somehow evaluated. And when I ask JS-like, show me sprint of x, it shows me the chunk. So it's not evaluated yet. However, if I will run x, it should be evaluated because it needs to be evaluated for printing. It says false. And when I check the sprint again, I see it's now evaluated to false. Okay, so far so good. Let's look at other example. Let's say I have this function, which is 1 + 2. This expression as well is not evaluated yet, right? So I'm using this sprint to see what's there. Yeah, as expected, it's still chunk. And the same way we've done before, I call this function and it's evaluated, it's showing me 3. And now let's check what's with this function. Oh, it's still chunk, but how it happens? Because you see that there were 3. Why it's not evaluated? Well, it actually because the default, the function I specified, it's actually have the num constraint inside. It's not a function of integers. So when we print that, yeah, we're defaulting to the int as JS-like does that. However, it's still not evaluated as we don't know what exact type is used in there, and it still is as a num constraint there. Good, good. Let's talk a bit about laziness. Yeah, we love laziness. It can give us a lot of benefits and a lot of headaches, thinking about the performance and memory and stuff. But let's now talk about this example. Let's say we have this function with a lazy constraint inside. We are not using that, and just returning the first element. Also, as it specifies that we need as a second element is something of a num constraint. Yeah, let's look at this two strings classing, which is actually doesn't make sense. So the compiler errors, it says that there is no instance. However, if I call it in the function, it doesn't complain about that. It's lazily doesn't even check anything on that, and it will normally return as 42. This is what laziness does sometimes. Okay, another thing that I figured out not that long ago, actually. Let's talk about main. Usually, how do you write main? You write main of type IO of units, and yeah, you do some stuff in there and return unit always. I thought that it's the rule that main should be the unit. However, did you know that you can use any type inside IO for your main function? Yeah, you can write this like this, and yeah, it'll work perfectly. I'm not sure I know how to apply that and why, but you can do that. Why not? Now let's look at some very interesting things. Okay, here we have a lambda function that uses least comprehension feature and doing something I have no idea yet what is actually doing. I don't see. It's like all X's in here. What's happening? I don't quite understand that. Let's rewrite it a bit. So if you add, if you name your variables differently, you actually can see more about what's actually going on here. You see that first we have XS, and then we have even smaller XSS. So what's happening here is just concatenation, concat function, which takes a list of the list and pulls it out. So now it makes more sense. So there are two ways of writing the same stuff, and both are working, but some of them are unreadable. And another thing that usually bothers me, I have a bad time understanding how do notation works with list. So this code will actually return you the list of pairs, not just this tuple. And yeah, this is something that I trying to avoid when I'm writing code, because for me it's very difficult to understand what's going on actually and how it's working. But I recently saw a very nice illustrated example, so check it out if you're curious what's going on here. Another nasty thing you can do is to specify the ID function, which won't always work as ID, and sometimes it could change your type, change your value. Specifically here, I'm specifying with a typable type class constraint on the function. I can do actually this nasty thing with the equality on the type level, and I'm checking if that type is bool, then I'm not using ID. I'm using not functions, which will give me the opposite result, and this will work. So it will work as ID on all the types except for the Boolean. It will work as not function. Okay, for now we were talking about the weird stuff in code we can write. However, sometimes errors could be even weirder. So you can write perfectly written, interesting code. However, errors are not that friendly. And yeah, the first example that comes to mind is a servant. You remember servant without the generics, and these longish error messages which gives you no clues about what's wrong and how to fix it. However, with generics, you also can have very weird errors. For example, here's reduction stack overflow. And yeah, I don't know what that means, but that also could happen. It's not easy to debug and get what's going on. Another thing that compiler can do is this. Let's have this data type, which is swap either, which actually either with a swapped parameters. And yeah, you could want to derive functor, and it should work okay, right, with the deriving functor on. However, no, compiler is not that smart to do that, even though by hand you can write this this parser. Okay, however, compiler can't do that for you. Okay, I always wonder what was the maximum capacity of having tuples. Usually I stopped at 3 and created a data type for the structures that require more fields. However, I see some instances sometimes in libraries which cover much more than just 3 elements. I could continue showing some example in the QI room if anyone interested. That was, yeah, the talk about all this weird stuff. So thank you very much. If you have any questions, let's do that.
All right, Veronika, thanks a lot for all the laughs. I just wish we had a live audience so that we could have some laughter, but I'm sure everybody's laughing their asses off in the chat. Right.
Okay.
Okay, everybody.
Okay, see
Let's.
you in the question room.
Yeah, let's go to the Q&A room.